Chapter 5, Laws of Motion. Yes, today's topic is Dynamics of Uniform Circular Motion. Yes, what is uniform circular motion? You know about it. Uniform circular motion. Uniform circular motion. When object is moving on circular path with constant velocity, it is called uniform circular motion. And we know that in uniform circular motion, acceleration is towards center. Acceleration is towards center. Yes or no? Yes. In uniform circular motion, acceleration is towards center of circular path. And we also know what is centripetal acceleration. Centripetal acceleration AC is equal to, here it is, v square upon r. If r is radius of this circle. Okay, so yes, we know what is uniform circular motion. If object is moving with constant speed on circular path, then yes, acceleration is towards center of circular path, and that acceleration is called centripetal acceleration. AC is equal to v square upon r. Okay, now what is Newton's first law of motion? If there is some external force, then acceleration is produced. If external force is zero, then yes, object is at rest condition or moving with uniform velocity. But here in uniform circular motion, as object is performing accelerated motion, yes, there must be some force which is acting in direction of acceleration. So yes, when object is performing uniform circular motion, in this uniform circular motion, yes, velocity at each and every point, it is in direction of tangent. Okay, as this centripetal acceleration is towards center, force, it is also towards center. Force acting on object is also towards center, and such a force is called centripetal force. The force which produces this acceleration, the force which is required for this circular motion to produce such acceleration is called centripetal force. Clear about this? So yes, in uniform circular motion, object is performing circular motion with this acceleration, and for this acceleration, okay, for circular motion, for uniform circular motion, FC is equal to MAC is equal to M v square upon r centripetal force. Centripetal force is required. Clear about this? So yes, now this point you have to remember. Whenever object performs uniform circular motion, FC is equal to M v square upon r, centripetal force is required, and this centripetal force is acting towards center. Clear about this? So yes, this point you have to remember. Okay, again, uniform circular motion. We know that at each and every point speed is constant but velocity changes. change in velocity, accelerated motion, acceleration is towards the center, centripetal acceleration is equal to v square upon r. Now if mass of object which is performing motion, okay, is m, then for circular motion Fc is equal to m, AC is equal to mv square upon r, centripetal force is required, and this centripetal force is acting towards center. This centripetal force is acting towards center. Clear about this? Now, in different cases, we will study how this centripetal force, how this centripetal force now depends. Now, how this centripetal force depends. For example, you know motion of planet around sun. Motion of planet around sun. Okay. So see here, if sun, planet, then yes, we know that planets, they are revolving around sun in circular orbit. So for circular motion of planet, around sun, required centripetal force is provided by yes, which force is acting between planet and sun, which governs their motion? It is gravitational force. So yes, for circular motion of planet around sun, required centripetal force is provided by gravitational force. Clear? So yes, you have to remember this point. See, object will perform circular motion. Now, why it is performing circular motion? Due to which force? That is different for each and every situation. Yes, it is performing circular motion means it has some centripetal force. But which agency provides, which phenomena provides that centripetal force? In case of sun and planet, okay, planet is revolving around sun. So yes, in this case, required centripetal force is provided by gravitational force. Another example you know, it is nucleus. And electrons are revolving in orbit. So yes, for circular motion of electron, around nucleus, required centripetal force is provided by yes, nucleus and electron. See, in this case, governing forces are gravitational forces, but in this case, for these fundamental particles, force acting between them is electric force. So yes, for circular motion of electron around nucleus, required centripetal force is provided by electrical forces. Clear about this? So yes, such points you have to remember. See, these are examples. Okay, now we have to discuss about cases when vehicles are moving on road. Yes, uniform circular motion means it is not always required. Yes, you have to move on complete circle. No, it is not necessary. If you are moving in some hilly area, then see, if roads are like this. So yes, I can consider such road as circular road. I can consider such road as circular road. So yes, whenever vehicle is moving on such path, whenever vehicle is moving on such a path, we can say it is performing circular motion. We can say it is performing circular motion. Clear about this? Okay, so yes, when vehicle is moving on such a circular path, then what is centripetal force, or centripetal force is provided by which agency? Centripetal force is provided by which agency? Okay, so now yes, we will discuss about this topic in chapter number 8. We will discuss about this topic in 12. Okay, but right now for this uniform circular motion, we will study motion of vehicle. Motion of vehicle on level circular road. Motion of vehicle on level circular road. Okay, what is meaning of level circular road? What is meaning of level circular road? Level circular road means on horizontal surface but circular path. On horizontal surface but circular path. Okay, so now we will first see first case, that is what is motion of vehicle on level circular road. It is clear why it is named dynamics of uniform circular motion. Yes, it is performing uniform circular motion, but why? Due to centripetal force, cause of motion. That's why it is named dynamics of uniform circular motion. Okay. Now we will see first case, that is motion of vehicle on level circular road. See, for example, it is circular path having its average radius r, and one vehicle is moving on this circular path. Okay, so let vehicle is moving on circular path. Vehicle is moving on circular path of radius r. Mass of vehicle is m. Mass of vehicle means total mass. Okay, mass of vehicle is. Now, first of all, we will identify total numbers of forces acting on vehicle. Okay, forces acting on vehicle. Forces acting on vehicle. First, always that mg, that is weight in vertically downward direction. In vertically downward direction. Okay, yes, how to indicate in this figure? Yes, I can indicate mg in this direction. Yes, it is mg in downward direction. Clear about this? If on road, vehicle is like this, then yes, mg is acting in downward direction. Mg is acting, yes, it is not in air, okay? Yes, it is acting in vertically downward direction. Clear about this? So yes, this vehicle exerts mg force on road. So obviously normal force, it is acting in this direction. Yes, normal force, it is acting in this direction. Clear about this? So second force is N, that is normal force. That is normal force, which is normal to contact surface, which is normal to contact surface, means road. Clear about this? So yes, on vehicle, these two forces are acting. First is mg, that is always in vertically downward direction. Normal force, contact surface is road, so it is acting in upward direction. And what is third force? That is Fs. That is Fx. Friction force. Which is acting parallel to road. Which is acting parallel to road. Clear about this? So yes, title is motion of vehicle on level circular road. Whenever vehicle is moving on level circular road having radius r, numbers of forces acting on vehicle, mg vertically downward, and normal force, normal to contact surface, fs, that is friction, which is parallel. Now yes, if you have observed, on level circular road, vehicle is moving in horizontal plane only. Is it moving in vertical plane? Is it moving in vertical plane? No, it is not moving in vertical plane. So here vehicle is not moving. Vehicle is not moving in vertical plane. Not moving in vertical plane means it is in equilibrium in vertical plane. It is in equilibrium. It is in equilibrium in vertical plane. Okay, see, if I am moving like this on this circular path, it means I am moving in horizontal plane. I am not moving in this vertical direction. Okay, I am moving not like this. I am moving only in horizontal plane. Clear about this? So yes, vehicle is not moving in vertical plane. It is in equilibrium in vertical plane. So in vertical direction, which two forces are acting? mg, that is always acting in downward direction, and normal reaction in upward direction. So we can say it is in equilibrium means force acting in downward direction is equal to force acting in upward direction. So mg is equal to n. Clear about this? Or we can say mg is balanced by this normal force. Okay, mg is balanced by this normal force. So yes, we can say these two forces cancel out effect of each other. These two forces balances each other. So yes, if these two forces balance each other, then which force is remaining? Only Fs, that is friction. Only Fs, that is friction. Then obviously, for circular motion of vehicle on this road, if n and mg cancels effect of each other, then which force is remaining? Fs. Then obviously that remaining friction force provides required centripetal force. So yes, here for circular motion of vehicle, required centripetal force is provided by friction between road and wheel. Clear about this? So yes, in this case you have to remember, for circular motion of vehicle, which force is required? So yes, it is friction force. Clear about this? In case of sun and planet, it is gravitational force. In case of electron and nucleus, it is electric force. In case of vehicle moving on level circular road, required centripetal force is provided by friction force. Required centripetal force is provided by friction force. So yes, here I can write required centripetal force. Fc is provided by static friction. And yes, Fc, if what is mass of this vehicle m, what is radius, it is r, then I can write it is m v square upon r. So yes, this point you have to remember. For circular motion of vehicle, required centripetal force is provided by friction. Fc is equal to Fs is equal to mv square upon r. Now, see, this speed of vehicle on circular path depends on friction. Coefficient of friction. If you are moving on some circular roads, then yes, if you have seen that signboards, okay, yes, for four-wheelers, speed limit is 60 km per hour. Okay, for heavy vehicles, speed limit is 40 km per hour. Then why that speed limit is given? Why that speed limit is given? Because on such circular path, if your speed is more than some specific value, you will be thrown away. Yes, in daily life, whenever you are moving your vehicle on some turn, you have to decrease your speed. Why? If you do not decrease your speed, yes, you will be slip away. Clear about this? So yes, what is condition? Okay, on such circular path we can move with some speed safely. Okay, speed of vehicle V must be such that required centripetal force must be less than or equal to maximum static friction. Okay, if friction is more, you can move your vehicle easily. Clear? So yes, what is condition? Speed of vehicle V must be such that required centripetal force is less than or equal to maximum static friction. Then vehicle will move safely. Clear about this? So yes, you have to remember this condition. Now from this condition we will obtain one equation. See, required centripetal force means mv square upon r is less than or equal to maximum static friction means Fs maximum. Yes or no? Yes, it is. Now see this side. Here it is. Fs maximum. Yes, you know my equation. It is mu s into m. Yes or no? But what is n? N is equal to mg. So here I can write Fs maximum is equal to it is mu s mg. So here I will put its value. See, m v square upon r is less than or equal to mu s mg. M cut. So v square is less than or equal to it is mu s rg. Clear about this? V square is less than or equal to mu s rg. Now we will find maximum speed on circular path. V square is less than or equal to mu s rg. So what is maximum value? Yes, maximum speed. For maximum speed I can write V square maximum is equal to mu s rg. Less than or equal to means it is less than for that particular value, also equal to. For maximum speed I can consider V square maximum is equal to mu s rg. So V maximum is equal to under root mu s rg. It is equation of maximum saved speed. It is equation of maximum saved speed on level circular road. What is meaning of this? If it is one circular road and speed limit means V maximum is given 50 km per hour. If vehicle is moving with speed 10 km per hour, 20, 30, 40, yes or no, then yes, vehicle will move safely. But if vehicle moves with speed V which is greater than V maximum, then vehicle will be thrown away. So what is meaning of this V maximum? You have to understand. V maximum is maximum safe speed on level circular road. And yes, whenever you are moving on some highway, you will be given such signboards. Okay, here on this road, maximum safe speed is 60 km per hour. Maximum safe speed is 80 km per hour. So yes, you have to drive your vehicle within this limit. Also, now observe your motion whenever you are moving on curve path. Okay, whenever you want to turn, you have to decrease your speed. You have to decrease your speed. Otherwise, you can easily understand. Okay, so yes, it is one important topic. What is uniform circular motion? What is centripetal force? And this first case, which is motion of vehicle on level circular road. Okay. Now, second case is if it is not level circular road. Level means horizontal. But if we have inclined circular road, then what happens? We will see in next lecture.